It's a really hot topic that you may have been already aware of. So a lot of techniques out there to actually squeeze out performance from foundation models and small language models, but one that's really getting a lot of attention research-wise as well as from a lot of our customers is fine-tuning and model customization, right? So today we'll go through right from the basics to two really cool applications of fine-tuning, one with Anthropic models and the other one with meta models. But we'll go through what fine-tuning really means, what that life cycle looks like for these models, and what are some relevant features on Amazon Bedrock that are related to fine-tuning and customization, right? So what really is fine-tuning, right? So it's basically the process of taking a pre-trained model and customizing it with your data, right? And the way to get to that pre-trained model is through first a large corpus of unlabeled data. So large organizations, organizations who have tens of billions of dollars to throw at this problem will generally pre-train their models to get to a baseline level of capabilities, from which all of us can fine-tune it with our task-specific data sets, as you can see here. So you get to a foundation model that is generally capable across multiple tasks and multiple languages and domains. And then you take labeled task-specific examples that are generally prompt completion pairs, essentially, which is here's the input and here's my expected output. And you use that as a training data set to fine-tune your base model to get a fine-tuned model that's specific to your use case. We've seen so many customers do this for their domain. So if you're in the financial services domain or in the healthcare domain, your vocabulary is different, the task types are very different. And so the more you fine-tune it with relevant and high-quality data, the better your final results are going to be at that particular task, right? So if you look at the broad life cycle of fine-tuning, we usually start with a use case, right? And that use case you might think of as let's take a document and summarize it in 2 lines, right? So even though it seems really simple, that's a difficult task for many LLMs today to accurately capture all of the document's details in 2 lines, for example. So that could be an example of a use case. Another use case could be, for example, text to SQL. Right, so I have a text query that I want to convert to SQL, which will then hit an analytics backend or a warehousing backend to get the data that I can plot or visualize in my BI, right? So lots of different use cases, but that's where we start, which gives us a clue as to what kind of data we actually need, right? So that's where our data prep comes in, where we need to clean the data and enrich the data, make sure it's deduplicated so that it's not the same data that you're kind of training on twice. And what we've seen with a lot of both research as well as actual production applications is that high-quality data is kind of the biggest differentiator that you can have when you're pre-training. So high-quality data will definitely lead to a higher quality model at that particular task type. So even today, a lot of organizations spend time and resources and a lot of human labelers that are well paid to actually label these data and use that for fine-tuning, right? So once you have this data prepared, you can use a host of different frameworks as well as services. For example, on AWS, you have Amazon SageMaker, as well as Amazon Bedrock, and a bunch of other services where you can actually do fine-tuning of your models and customize it based on this data that you've already prepared. While you're doing this customization, it's always desirable to have monitoring in place so that you know how this fine-tuning is going, and you can kind of interrupt that job, for example, and restart it with different hyperparameters. And we'll talk about hyperparameters quickly in a later slide. So let's say you've done that, you've trained your model, and your validation metrics look fine. It looks like your training actually did result in something that was different from the base model. That's when we do an evaluation with a completely blind test set, right? So we were talking about 2 different tasks, document summarization as well as text to SQL, right? So you can have a blind set of text to SQL tasks that is your test set, and you can evaluate it against it. A lot of our customers, as you know, are working with retrieval augmented generation. They have their own evaluation metrics, and for example, Amazon Bedrock will provide these managed features. It makes it easy to evaluate your customized models as well. So the big question is, when should you actually fine-tune? There's a lot of these different techniques. You've all tried, I'm sure, prompt engineering. You've probably also tried RAG, or retrieval augmented generation, where you can get context from knowledge bases, and you can use that to augment, to make these responses better. And then you also have fine-tuning. And it's in that order of complexity that people try things, right? So you want to try prompt engineering first, and that gets you, let's say, half the way there. You can use really high quality prompts that are optimized. We recently released a feature on Amazon Bedrock that automatically optimizes your prompts for a particular use case. So you can do that. You can also take RAG, for example, where you have a knowledge base that's either stored as vectors in a vector embedding index, or it could be in a graph format, and there's various formats in which you can store this company knowledge behind the scenes. And when there's a question from a user, RAG basically will retrieve all of these relevant documents or source chunks, and you can use those source chunks in line with your question to actually get better answers. And then we are talking about fine-tuning today, right? So going from kind of low complexity to high complexity, top to bottom there. Let's say you want to make your model follow a particular tone, right? So you're, say, in the customer service industry and you wanted to follow a particular tone. You might see that prompting or prompting plus RAG also has a pretty good success rate at doing that, right? But then when you have fine-tuning, you'll see that you'll be even more successful when you have like a low complexity task like this. So going down the list again, let's say you want to teach this model a completely new skill, right? Let's say the baseline model was not really great at text to SQL, but now you want it to be really great at text to SQL. Then that's where fine-tuning does really well as well, right? So because this is outside the domain of expertise of the base model, and that's where you should seriously consider fine-tuning. Now, with that example in mind, you can pretty much say that the text-to-SQL model that you fine-tune is going to do well in that particular set of tasks. But if it's a slightly different kind of SQL, or if it's GraphQL, it's not going to generalize well in multiple other tasks, right? So this is where even with fine-tuning, you can expect it to do really well at a particular task that you teach it to do, but then it's going to be less likely to generalize well across multiple similar task sets as well. In the last case, where if you want to teach a model some new set of knowledge and has to use that knowledge to actually solve tasks, that's where it's even lower likelihood that fine-tuning will work, right? So think of it like you're fine-tuning for a particular task, and it can do really well at that task, and you can evaluate it at that task, and you can be super confident that it'll work there. But it's two sides of the same coin. So if you want to generalize, you're better off using a base model or prompting and RAG as well. So when you're doing fine-tuning, so what are some of the key considerations? It depends, and unfortunately, that's the best answer we have so far. So there's no really straightforward answer, right? So let's say there's new concepts that the base model is already familiar with, and you wanted to learn through small-scale fine-tuning, then that's a really great use case. Like I said earlier, with some of these use cases, you have specific tasks and specific things that you want these models to do, and you can expect that fine-tuning does a great job there. When you see promising few-shot results, right? So few-shots are basically inline examples that you can attach with your instructions or your prompts, and these few shots actually help the model respond in a particular way, and you can solve things like tone and even improve accuracy on tasks by providing these few shots. This is where you can think that if few shots work well, then fine-tuning with lots of similar shots is actually going to work even better, right? So that's a good indication or an early indication for you to consider fine-tuning. Also, when you look at prompt engineering, usually we start off simple and then we keep expanding the prompt and we end up with a huge, really complicated prompt. And now our task is to see if our model actually follows all of our instructions, if it solves the problem at hand, and if it relies on the constraints well that we place in the prompt. So in the process of doing that, you might end up with a huge system instruction as well as prompt, as well as a set of examples that may work well, but you're working against the token budget that you might have, in the sense that you're sending in more input tokens, which will cost you more. It might still give you the answers that you need, but you're still paying for the input tokens, right? So fine-tuning, again, is one way for you to not do this elaborate prompt with, we've seen customers with hundreds of examples in the prompt itself. So now you can fine-tune with those examples and then use that fine-tuned model with a shorter prompt, right? So you're paying less for the input prompts. You're paying pretty much the same for the output prompts as long as you're on the same inference stack. So now that we know a little bit about fine-tuning, there's a few Amazon Bedrock features that I'd like to talk to you about. There's, of course, one called Bedrock fine-tuning, where you can pretty much have a simple data set, right? So we talked about prompt completion pairs in the first diagram. So you can take a JSON lines formatted data set there. You can put it up in S3, and through either the console or through the set of APIs that we have, you can start a model customization job, which fine-tunes a base model, and at the end of it, you have a model artifact that is specific to your use case or your task type, which can then be used through provision throughput, which is basically a standalone endpoint for you to hit as an API. So this is where you can integrate it with your end application. And while you're doing fine-tuning, at least Amazon Bedrock will give you the most important parameters that you can control the outcome of fine-tuning with. These are called hyperparameters, right? So high-level ways to really control the fine-tuning. This can be the learning rate. It can be the number of epochs or how long you want to run the training. It can be number of warm-up steps, for example. And these are all well documented. The takeaway is that the fine-tuning capability on Bedrock keeps it really simple, right? So you don't have to worry about setting up your frameworks, setting up your instances, SSHing into it, and then managing a cluster. So it's select a model, make sure your data set is in the right format, and then use the right APIs to get your fine-tuning started. Although this is very rare, continued pre-training is also a managed feature within Amazon Bedrock. The reason it's rare is because this takes usually a lot of high-quality data as well as a lot of time and resources to train on. As an example, right? So you've heard of the scaling laws. Scaling laws essentially map an optimal model to the number of resources that you have to attach to it to actually fine-tune it, right? Roughly. And so if you do the calculations and if you want to train your own 1 trillion parameter model and you want to start your own company with that, and you have 1 trillion tokens of high quality data, it'll take you about $20 million to pre-train this model. So if you have $20 million lying around, let us know. We'd like to talk to you. But there are other cases where you can take a smaller architecture and you can pre-train it. Some of our models that we released earlier this week, so the Nova Micro, Nova Lite, these are smaller models that were pre-trained with the same kind of process in mind. So you have a large corpus of unlabeled data, and you can pre-train your models and then fine-tune it subsequently and then align it, and that's how the entire life cycle looks like. So once again, with continued pre-training, as long as your data set is in the right format, is in S3, you can select the base model architecture in this time, and it's not a base pre-trained model anymore, and you can completely train this model from scratch. And there are good reasons to do that, although it is rare, like I said. In most cases, fine-tuning should do really well in your use cases. One really important feature that we released, not during this week, but a couple of months back, was a custom model import. So let's say you had one of the popular architectures of models out there, and you've fine-tuned it separately outside Bedrock, whether that's in SageMaker or EC2 or on Hugging Face Auto Train or on your own laptop. As long as it's a Llama model or Flan T5 model and a few other supported model architectures like Mistral, you can actually take that model and you can import it into Bedrock, where you can use the Bedrock invoke model APIs directly to hit your own models, right? So this makes it really flexible. So you don't have to actually use the Amazon Bedrock fine-tuning features to then invoke the model on Bedrock. Even if you had a separate model out there that you fine-tuned on your own, you can import it using this custom model import feature on Amazon Bedrock, and you can hit the model right there. What's really interesting is also one really attractive feature of Amazon Bedrock is the marketplace of models, where you can invoke a model, only pay for the tokens that you use, or the input and output tokens. So with custom model import as well, even though it's your own model, you're paying token-specific costs, right? So that makes it really interesting to at least test out the model first. And then when you're really interested to integrate it with your application, you can go through provision throughput and get your own endpoint for your specific model. One last feature that we just released as well is Bedrock model distillation. Yan, who's a co-author, she has a great guide that's already published that you can go through. Basically, the idea is that you take a larger, more advanced, more capable model to generate, prompt completion pairs, which can act as labeled data sets for smaller models, right? So let's say you had a specific task in mind. You can take, for example, a Llama 405B model, and that's a large model that is general purpose. And one really great way to use the model is to generate data sets and then train a smaller Llama model. And that could be a 1B model, it could be 8B model. And so with Amazon Bedrock's model distillation, makes it easy again. All you do is you select a teacher model and a student model, and you can provide your data set as an S3 file. What's really cool as well is if you have production applications that are going through and using Amazon Bedrock's invocation APIs, then you also have logs associated with those invocations, which are input and output kind of pairs within CloudWatch logs. And so you can directly parse those logs and use that for training. And all of that is, you can go through a simple wizard on Bedrock, and you can also use the associated APIs. At the end of which you get, again, distilled model that is specifically fine-tuned for a task. The only difference being is you might have started off with very little to no data, and the teacher model is using that as examples to generate even more high-quality examples for downstream fine-tuning of the smaller model. So definitely give these features a try out, and the documentation, APIs, and associated blogs are also out. And that's that with our Amazon Bedrock features. Next up, we'll talk about customizing Anthropic Claude 3 Haiku specifically, followed by Isa on Meta. So over to you, Yanya.
Thank you, Shiraz. Okay, thank you, everyone. So I think Shiraz already covered quite a lot about the Bedrock model customization offerings. And now I would like to take the chance to help us take a closer look about customizing Anthropic Claude 3 Haiku. And during this time, I want to share some best practice and some learnings and our experimental result to just show you how you can really succeed with this feature. So I think Shiraz mentioned in the lifecycle, fine-tuning lifecycle, you first need to have a well-defined use case. And once you have that use case defined, then we are coming to the stage to start preparing our data. So for Haiku 3, fine-tuning, the requirement is you need to prepare a JSON-L format data. And this data needs to actually use the message API. And each line in this JSON-L represents one training record. And if we take a closer look at each line, the right-hand side is one of the examples we're offering here. The first is you can optionally have a system prompt. But this system prompt actually is highly encouraged, or let's say it's highly recommended to use, because we oftentimes find if you assign a role to the model, the higher chance the model will have a better performance. So like, let's say this system prompt is optional, but highly recommend here. And then you need to have a like required field called a message field. And inside this field, you need to have two rows. One row is the user role. The user role actually contains your prompt input. Say it's like your desired input later when you interact with the fine-tuned model. And you will also have an assistant role. The assistant role actually plays the desired output from the fine-tuned model here. These two roles need to alternate between each other, but actually we support multi-turn conversation. So actually that means in each JSON line file, you can actually have multi-turn conversation, like multiple user and assistant conversation, but just make sure they are alternate between each other, and they need to follow the message API format here. And once you have your data prepared, then we're coming to the stage to set up our fine-tune parameters. Here are the list of 5 parameters we support with Haiku fine-tune in Bedrock. The first 3 here are the required parameter, and the bottom 2 is the optional, but still highly recommend. So let's take a closer look at the first 3 first. The first will be the epoch count. The epoch is the maximum number of iterations through the entire training data set. And this one can be set up to 10. But with the Haiku fine-tune, actually, we allow you to do early stopping if you provide a validation data set. And if you use the validation data set, that means probably you don't really need to really have your entire fine-tune job complete within your specified epoch count. This would just be the maximum number that you set. And the second parameter is the batch size. The batch size is the number of samples processed before updating the model parameters. And this batch size is actually highly relevant to your number of training records. And the next slide, I'm going to actually talk that in more details. But just please keep it in mind, this one is highly relevant to your number of training records you have prepared. The third one will be the learning rate parameter. This is just like a multiplier that influences your learning rate. And this learning rate later we can also talk about. This one, by default, we set that to 1. And we encourage a customer to start with 1 here, because that is after our science team done extensive experiments. They found 1 with this learning rate parameter would work the best. And then the bottom 2, the early stopping threshold and early stopping patient are optimal. But once you provide the validation data set, you can enable these 2 to do the early stopping. So what is early stopping? Early stopping is a technique to help you prevent overfitting by actually stopping your training job if your training job, if your validation loss is not decreasing over time. So in Haiku fine-tune in Bedrock, basically, if we see your your validation loss is not decreased enough within the specified times, here, I mean enough is actually the threshold we specify here. And the patient actually defined your times. If we say, okay, it's not improving, or let's say the validation loss is not decreasing enough by certain times, then we will stop the training time. Even it doesn't really meet your epoch count specified here. So then I think the next question is, okay, now we understand these parameters, how to set it up, what's the right number for these parameters. So first is the learning rate. Like we discussed, learning rate by default, we would suggest you to start with 1.0 because that is from our scientist experiments. And you can actually adjust this value based on later your evaluation. And the second is about batch size. So batch size is highly, the optimal value can highly vary depending on your data set size. If you have a training data that is over 1,000 records, then we will suggest you to consider using a higher batch size. Versus if you have a medium size, between 500 to 1,000, maybe it's time to consider using 16 to 32 as your batch size. Versus if you have a relatively smaller data set, less than 500, then let's try to use a smaller batch size from 4 to 16. And our experiment shows, in the scenario, where you have a lot of training data, normally we say a lot between 1,000 to 10,000, the learning rate tend to have more impact. Versus if you have a smaller data set that is normally less than 100, batch size will become the dominant on your fine-tuning performance. And once we have a fine-tuned result, then let's come to take a look at the performance evaluation here. So we assume we are using the target use case as a TED QA dataset. This dataset is publicly available, and this is doing Q&A on financial text and tabular contents. And we train our model using 10,000 records from this TED QA dataset, and evaluate that using about like 3,500 records, and we're evaluating using the word matching F1 score here. And after we have done the experiment and we try different setup, we see the best performance we can get from the fine-tuned haiku would be about 91.2% accuracy. And that is actually better than the base haiku, than the Claude 3 Sonnet, even than the most advanced 3.5 Sonnet model. And the improvement, like the model improvement, performance improvement is like it can beat base haiku for about 25%. And it can outperform the Claude 3 Sonnet with almost like 20%, and can also outperform the Claude Sonnet 3.5 for almost like 10%. And another thing I would like to also highlight here is about in-context learning. So we hear from customers, they were asking, okay, I have already fine-tuned my model. Should I still use in-context learning? And the answer is yes, you should still consider using in-context learning, because in-context learning will help improve the performance on both base and fine-tuned model. So if you really want to push your model to the best performance, consider using in-context learning together with fine-tune to achieve it. And the last slide I want to talk here is about another benefit to use the fine-tuned model. It's about reducing the token usage. I think we often know like output token normally will actually lead to higher latency and also higher cost. But by using fine-tuning, actually you can have a more efficiency here with your like model output token usage. So you can see here, still using our TED QA dataset as an example. With the base haiku, the average output token will be about 34 tokens, versus with the fine-tuned token, we have about average output token like 22. That implies a 35% improvement here. And if we take a look at the histogram here, you can see the fine-tuned haiku like has very dense like distribution. That means the most output will be very concise, versus like the base haiku normally tend to generate some unnecessary information. And I would like to close my part to show you an example here. So you can see the left corner, we have a question. This question is from the TED QA dataset. They have a simple question like, how did the company adopt this topic? And the ground truth answer is also very like concise. It just shows like probably 4 words here. But normally base haiku tend to give you some unnecessary explanation here. So although we can see factually this answer was correct from base model, it just like tend to be more, tend to be not that efficient. But the fine-tuned haiku, on the other hand, actually aligned with the ground truth 100%. It generates a very factual, like correct result, but in the meanwhile, it gives you very concise output. So now I would like to invite Isa to talk about customizing metadata available in Bedrock.
All right. Thank you, Yan and Shreyas. So I'm Isa. I'm on the, again, the AI partner engineering team at Meta. And I'm going to be going through customizing Meta's Llama models. And I'm going to go ahead and go through a few use cases which really do benefit from fine-tuning. I might do a little bit of showing you guys an example or two, and then we'll go through a little demo on showing an example of doing a little distillation and fine-tuning an 8B model to improve its performance. So pushing forward here. All right. So Meta's Llama 3 fine-tuning use cases. So what I have up on the board are basically a handful of use cases which really do benefit from fine-tuning. And the reason I wanted to put this up here is to really give an example to answer the question that's really common. Why do I need to fine-tune? Or why is Llama's model not working as performant as I want it to be when I'm prompt engineering and just using RAG, but I haven't fine-tuned? So as you see here, we've got 5 examples, and this is just a handful of them. There's a lot of other use cases out there too. But in this, you can see customer service chatbots. How does fine-tuning help with customer service? Well, being able to really understand a business's customer queries and having the context of that business's internal knowledge, their products, et cetera, becomes very advantageous and improves the performance. Content generation, being able to really tailor it to a brand's tone, their style, all of these things is super important. And then you think about compliance and regulatory analysis and financial chart analysis. All of these can be very highly specific to the organization, that enterprise's demands. And in finance, it could be very specific to those indicators for that company or the particular analysis you're trying to do. So these are just a few examples, but really diving into fine-tuning a little bit more and touching a little bit more on what Shreyas and Yan were really providing a lot more detail on. Some of the most crucial parts of fine-tuning are really the data set analysis, the processing, ensuring you have basically a diverse enough, generalized, but specific data set which works well for what you're going to be doing. And as you can see on this deck, or on this slide, I'm trying to really emphasize a well-curated data set is critical or crucial to really be able to get the advantages of fine-tuning. If you don't have that, if it's not diverse enough, if it's not generalized, you might not get as much of an increase in performance and accuracy or whatever you're trying to do out of the work and resources you're putting into it. Again, I mentioned diversity. So that second point there talks about a diverse data set. It really helps to generalize the data, right? Domain-specific data set. So here comes the idea of domain-specific versus like a custom data set. So domain, obviously you have industry domains that you really want to tailor that data set to. So when you fine-tune, you've got more knowledge in that sense. But maybe you want to really fine-tune to a particular task or project. You're going to look at something like custom data sets in that sense. And as you can see there, custom data sets really are going to be designed to help you provide like a highly relevant and accurate result for that fine-tuning pass that you're going to do with that model. So now, pushing into just a really kind of high level here. So we publish Llama and our general defaults for fine-tuning in all of our examples. If you reference our resources that we put out on GitHub, so Llama is open source. We have our open source repos, Llama recipes, and Llama stack. Both of them are open, both of them are available. There's tons of examples with just how to do inference, how to do fine-tuning, how to run safeguards with like Llama Guard, et cetera. But in there, you'll see we also have examples of doing fine-tuning and doing full parameter or doing LoRa or QLoRa. They're all available there. And generally, we do publish with the recommended parameters we guide you to start with. And as been mentioned, I mean, that might change depending on what you're doing. And for every case, it's going to be dependent on what does your data set look like, what's the size of it, what is your need, do you have enough validation, and that's really what's going to dictate that. So in this, I've also got a couple of links just to a couple of examples. I know everybody here is technical, so you might want to just go ahead and find one of these links and click on them, and you'll find end-to-end RAG examples with a chatbot. That's something you can go in there, look at how it's done, or just deploy it as is and start playing around with it and modify. I've also put a link to basically a recipe for our multimodal models that we released a few months ago, so Llama 3.2. We released the multimodal, which are text and image in, and then text out. So there's a few examples in there. Now, what I want to really harp on here is how fine-tuning can help. So in this example, I'm really abstracting what's going on, but I'm showing you an example of running this simple analysis. It's basically like a problem solving of a math problem with the Llama base 8B model versus a fine-tuned 8B model. And you can see with the output of the Llama 3 8B model, it doesn't really make sense. The calculations are a little bit off. But then when you actually look at the fine-tuned version, it was able to reason through what the instructions were in the question. It was able to put it into pretty simple, straightforward words, and it properly does the calculations. So just a super high-level example of how fine-tuning really makes a huge difference in being able to produce something that is a valid output that's accurate as well. And again, very simple, but let's go ahead and move over to a demo here. So I'm going to move over to my laptop. All right. Looks like we're live on there. So in this demo, what I'm going to be showing, this is a readily available notebook that you guys can access already on GitHub. So this is one that we worked on with AWS, and they published it on their Llama on AWS repos. And we've got links to it within Llama recipes as well. So in this notebook, what we're demonstrating here, we're walking you through, and you could run this step by step on your own if you wanted to. Taking the 405B model, whether you run it on SageMaker or Bedrock, it is available there. Getting a data set from that, so using distillation to then teach an 8B model. So you're going to fine tune that 8B model to improve its performance. So I'm going to go ahead and move down to the code just so we could skip a lot of this text in here. So prerequisites, just really quickly, you will obviously need an AWS account. You need access to SageMaker. You need access to Bedrock. You'll need to set up your IAM configurations, etc. I won't touch too much on there. But let's go ahead and dive in. So what we're going to actually perform in here is we're going to deploy a Llama 3 8B instruct model. And we're going to use the Aquarat dataset, which is basically a large collection of about 100K algebraic word problems. And it's really a great data set for training and evaluating models on their performance and being able to really reason using natural language through algebraic problems. So in the beginning here, basic imports. We're going to begin touching on basically configuring the data set. And you'll see here that we're actually going to go ahead and begin loading the data set. And we actually print it out. So we're just doing this as an example. So if you guys do take this notebook and deploy it, you could see what does this data set actually look like. We're printing a limited number in there. You could see from the code that we limit that down here in these lines, just so you're not printing out 100K plus examples. We get that split up properly as well. But that's what this output is here. So this is just a limited subset of the data set, so you can take a read and know what you're actually playing around with. The next thing we do in this example, or in this notebook, is we actually deploy the 8B instruct model. And then we're going to go ahead and run it. And we're going to go ahead and run a problem through it, and we're going to see that its output, before being fine-tuned and trained, is not 100% accurate. It's not 100% aligned with what we want. If we were just to run that with 405B, the same exact prompt, you see significantly better output. So that gives you an idea that if you used 405B and it is giving you a good response, it probably means that the output from 405B could be used to create some synthetic data or some data to then train the smaller models. So just kind of a food for thought mention there. So this is just that really quickly running the test of it without a fine-tuned 8B model. Now, in this next section, we begin deploying the 405B model. This code has two forms. We've deployed it on SageMaker, but you could run this on Bedrock. And we actually have an example down here where you could do it running Bedrock. So you can see we have the code here for optionally using this and creating your synthetic data using Bedrock, which is super advantageous. It allows you to throw out the whole idea of having to have a DevOps kind of understanding and know how to spin up resources, even though SageMaker abstracts a lot of that for you, but it simplifies things. So in this, again, you're going to go ahead, if you're deploying on SageMaker, you're going to deploy that instance, then you're going to go ahead and have the synthetic data get generated. That's what this code is doing. And then we're going to make sure we save that data. We save it out basically like a JSON format. You'll see similar being done on the Bedrock side. And this is all using the Bedrock Converse API, which is super helpful and useful in these cases. The next part of this is obviously we need to upload our data that we've generated from 405B to S3 for our training job. So in this notebook, we did our training using SageMaker, but you don't have to do that anymore. So with Bedrock, you can go and do your training of Llama 8B or 7DB on Bedrock itself. which is super advantageous as well. Again, you don't have to reserve resources, have that spun up on your own side, and you don't have to worry about that resources eating up cost if it's done running its job, right? So we'll go ahead and begin the actual fine-tuning of the 8B model. You'll see a ton of fun output in this case because we're running it directly. It's not the Bedrock output. So it's pretty verbose, and you can see all the epochs running here, all that output. So I'm just going to keep on scrolling just to move us along. And there we go. So now we're done. We've trained our 8B model. We have that fine-tuned. And now we're going to go ahead and deploy that model with this section here. So we've deployed, at this point, our 8B fine-tuned model that was taught by the output from the 405B model. And now we've got a nicely formatted table here to really show the impact of that fine-tuning. If you take a look, we've got the questions defined on the left column. We've got the fine-tuned output in that third column. And we've got the non-fine-tuned model output on the last column there. So I'm going to leave that up there. I'll just kind of summarize the conclusion here because a lot of it was touched on by both Shreyas and Yan, that the fine-tuning, one, obviously can increase the performance and accuracy of the model. It can adapt it to whatever the use case you're talking about is. But there's a lot in terms of also advantages when it comes to computational resources that you're going to be using, whether it's reducing token usage and basically your cost in that sense. But I'm just going to leave it there, and I will conclude my part at that point. So I think that wraps it up. I think all of us will be here in the room hanging out for a little while. So if you have any questions for any of us, please do. Feel free to come up and chat with us. Thank you.